All right, so here's lesson 3. So we're going to be talking about something called tangent lines in this lesson. I'll explain what that is in a minute here. So the warm-up here says line L represents a straight part of the shoreline at a beach. Suppose you are in the ocean at point C and you want to get to the shore as fast as possible. Assume there's no current. Segments CJ and CD represent two possible paths. Diego says no matter where we put point D, the Pythagorean theorem tells us that segment CJ is shorter than segment CD. So segment CJ represents the shortest path to shore. Do you agree with Diego? Explain your reasoning. You can go ahead and pause if you want to think about that for yourself. I'll go ahead and talk about it a little bit. So, he is correct that no matter where we put CD, unless it's right in the same spot as J, no matter where we put D, segment CD is always going to be longer than segment CJ, unless, of course, we put D right where J is. In that case, it would be the same length. So, I suppose a better way to say it would be that CD, no matter where we put D, CD is never going to be shorter than segment CJ. But if we think of it as D can't be where J is, then CD is never going to be, CJ is always going to be longer than CD. And that's, if you think about, he cited the Pythagorean theorem as his reasoning for that. So if you think about the Pythagorean theorem, a squared plus b squared equals c squared, those are the sides of a right triangle, right? And the hypotenuse is always c, and then the legs are a and b. Doesn't matter which one's which. So even if A was like 100 and B was like something really, really tiny, C would still end up being a little bit more than 100. And of course, if A was 100 and B was 0, then it wouldn't be a triangle. It would just be a line. So, so he is correct. The hypotenuse is always going to be the longest side, and this is always going to be the hypotenuse. So an important part of this figure is this right angle that's pointed out there. So what I want you to gather from this is the shortest path from a point to a line is the path that is perpendicular to the line. So you want to make a right angle. So let's write that down. The shortest path from a point to a line is the path that is perpendicular to the line. So, for example, if we have this, our line here, our shortest path is going to be whatever makes a right angle. As opposed to going like this or like this. So this here is going to be the shortest path. So not this, not any of these. The one that makes the right angle is going to be shortest. Okay. So now we're going to kind of see what that has to do with circles and tangent lines. So moving on to 3.2, we're going to have to draw some things. Do the best you can with the tools that you have at your disposal right now. So it says draw a radius in the circle. So I have a straight edge on my protractor here that I'm gonna use. If you have a ruler, you can use that, but we do wanna have as straight a line as possible here. So let's draw a radius. Doesn't matter where it goes to. Just remember a radius has to start at the center and then end somewhere on the circle. So there's my radius, and then I'm calling that point A right there. And then it says we want to construct a line perpendicular to the radius that goes through point A and label it N. So there is a proper way to construct a perpendicular line with a compass and things like that, but we're not going to bother with that. The important part here is just getting the idea. So I'm just going to use my protractor. This is some good practice for using protractors too. So I want to make a perpendicular line that goes through A. So basically what I'm going to do is I'm going to think of A as my vertex of my angle. And remember, a perpendicular line means it makes a right angle. So I'm going to use this as my vertex and then line it up here and then mark where 90 degrees is. And that's going to help me draw a pretty good perpendicular line. So I'm just going to line up with this now. And then just draw my line right through like that. So that looks decent. Have my perpendicular line there. Okay, and that is supposed to be called N. Put a little N there. Okay. Line N intersects with the circle at exactly one point. Why is it impossible for line N to intersect the circle in more than one point? You can go ahead and pause and think about that if you want to. I'm going to go ahead and explain this. So, if this line is perpendicular to this line, we know that the shortest path from this point to this line N is the path that's perpendicular to it. So, in other words, the shortest path from here to this line is this path right here. So this is the shortest path from point O to line N. So what does that have to do with, what does that have to do with knowing that this line is not going to intersect the circle at more than one point? Well, if this is the shortest path and A is on the circle, if we think about a circle, all the points that make up a circle are all the same distance from the center, right? So if A is this distance from O, then any other point on the circle must be the same distance from O. But if you think about the line, there's no other point on the line that's going to be the same distance from O. So if all the other points on the line are going to be farther away from O than A, and all the other points on the circle are going to be the same distance from O that A is, then no point on the circle can also be on the line. Therefore, the circle and the line cannot possibly intersect at any other point. So, I'm not even going to bother going through and writing all of that down, as long as you sort of followed what I was explaining. But the point is, based on all of that we just talked about, we know that a tangent line, whose point of tangency is intersecting the point of intersection with a radius. So let me word that a little bit better. So if we have a radius drawn to a point of tangency with a tangent line, the point of tangency is where the tangent line is going to intersect with a circle. So I guess let's rewind a little bit. So a tangent line, let me explain what a tangent line is first. So a tangent line is a line that intersects with a circle at exactly 1 point. So that means we have a tangent line here. Intersects with a circle at exactly 1 point. So that's what we should write down here. What kind of line then is n? N is a tangent line. So what that's going to tell us further is that if we have a radius and a tangent line, and they intersect at that 1 point, then these have to make a right angle. So if you want to go ahead and write this like in the front of your packet, you have that chart in the front of your packet. I don't have that exact piece of paper here, but I'm going to write it here for you. So here, we're going to have like some little sections here. So this is going to be a theorem. So what we're going to say is a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. And then a drawing, if you can draw a decent circle, and then radius. So the radius has to go to the point of tangency, because there's a lot of different ways you could draw a radius in a circle, right? You could draw one like over here, you could draw one over here, but in this case it has to be the radius that's drawn to the point of tangency. So if you have a tangent line, in order for this to work, you have to have a radius drawn to the point of tangency. So then this is going to be a right angle. Alright, I'm going to stop there for this video. We'll pick up with 3.3 in the next one.